the bioinorganic chemistry. So what is bioinorganic chemistry? That is microelements, macroelements, alternate trace elements. All these are explained in the last classes. Now this chapter will be continued. This is BSc 6th semester syllabus. So that is I will be continued. That is bioinorganic chemistry. The chapter is. So under that, what is called as metalloporphyrines. Metalloporphyrines. So what is metalloporphyrines? The metalloporphyrines will be present in the body in the form of what is called as hemoglobin and myoglobin. So the hemoglobin and myoglobin, these two are the important parts of our body. That is, the blood will be contains hemoglobin and myoglobin. The hemoglobin, it consumes oxygen through the respiratory system and it will be supplied to all parts of the bodies. And the myoglobin, it gains oxygen from the hemoglobin and it will be supplied to the different parts of the body, that is oxygen. So that is through oxygenated. So here, what is this metalloporphyrines? The metalloporphyrines means it will be having the four, that is what is called as the pyrrole ring systems. It will be having the four, that is pyrrole ring systems. The first one will be like this. This is a porphyrin, the ligand. So this is a porphyrin, the ligand. The structure will be like this. This is the N and this is the NH. This is a double bond and this is a double bond. N, a single bond H, and this is a nitrogen. So this is structure of what is called as porphyrin. So this is one double bond and this is another double bond. This is another double bond. Here there is a double bond is there and this is double bond and this is called as structure of, that is a porphyrin. This is called as a porphyrin. It will be having the four pyrrole rings as well as the four nitrogen atoms. The four nitrogen atoms. Then the second one is what is called as a metal porphyrin. The next structure is metal pore pyrene. So the metal pore pyrene, the structure will be like this. So this is this distance is 2 nm, the 2 nanometers. So further, so this is called as a metal pore pyrene. Metal pore pyrene complex. Metal pore pyrene ligand complexes. Ligand complex. So here in the metal pore pyrene complex means at the center there will be a metal. So the metals like what is called as a magnesium, iron. The M is magnesium or the iron, Mg+2, and the third one is what is called as a nickel, that is Ni+2. The nickel is the Ni+2. So this metal pore pyrenes will be having a pore pyrene structure. Is the first one is it will be having a 4 pyrrole rings. It will be having a 4 pyrrole rings. Is the 1 nitrous, the 2 nitrous atoms are tertiary atoms, and the 2 nitrous atoms are secondary, that is secondary atoms. So here this is the first structure is what is called as a pore pyrene structure. The pore pyrene structure is it is combination of the 4 pyrrole rings with the 4 nitrogen atoms. So the 4 nitrogen atoms, the 2 nitrogen atoms are in the position of secondary position, and the 2 nitrogen atoms are present in the tertiary nitrogen atoms. Then the metal pore pyrenes. The metal pore pyrenes means so that is central terminal metal is there. This is called as a M metal. The M metal means a magnesium, iron, as well as what is called as the nickel is. So here the metals M is that is called as magnesium, the Mg+2, the iron is Fe+2, and nickel is Ni+2. The nickel is Ni+2 means in this structure, this is the structure of what is called as a metal pore pyrene, the ligand complex. The ligand complex like what is called as a magnesium, the iron, and the nickel is. Either if magnesium is there, it is called as a chlorophyll is there. If iron is there, it will be called as hemoglobin and myoglobin, and nickel will be called as a different compounds. The different compounds. The chlorophyll present in the what is called as the plants. The plants are green due to what is called as the chlorophyll. It absorbs it absorbs from the sunlight, the oxygen, and it will be photosynthesis process will be continuous. But if a metal ion present, the metal ion will present, the second one is what is called as iron. So this iron will present at the center, that is the iron is there. So that is here, the M is equal to Fe plus 2. M is equal to Fe plus 2. It produces what is called as that is the hemoglobin and the myoglobin. The hemoglobin absorbs oxygen from the atmosphere and it will produce to all parts of the bodies, all parts of the bodies. So then oxytocin, the second one is myoglobin. The myoglobin absorbs oxygen from the hemoglobin. It produces to all parts of the bodies, all parts of the body. The remaining only here, the 70% of the oxygen will be carried by, that is what is called as the hemoglobin, and 3% will be carried by the myoglobin, and remaining the oxygen present in the body in the form of what is called as ferritin. This is present in the ferritins. So this what is called as a metal porphyrin, the ligand complex. It will be having at the center there will be a metal and it will be surrounded by, linked by what is called as a 4 pyron ring systems. All the 4 pyron ring systems, the 2 nitrogen atoms are what is called as secondary nitrogen atoms, and remaining the 2 nitrogen atoms are present in the what is called as tertiary nitrogen atoms. The tertiary nitrogen atoms. The porphyrins are one of the most important groups of the bioorganic compounds in which a metal ion is surrounded by the 4 nitrogens of porphyrin ring is. Okay, so porphyrins are made up of 4 pyron rings already linked together through a methane bridges. Therefore, porphyrins have a what is called as a macrocyclic pyron ring systems and conjugated the double bonds. So this is a conjugated double bonds will be like this as now the rings is there. So the next is these porphyrins act as tetradiene linkages. Tetradiene ligands with 4 nitrogen donor sites. With 4 donor sites. That this is the first nitrogen atom, this is second nitrogen atom, this is third nitrogen atom, and this is the fourth nitrogen atom. So they will be called as a donor sites because these bonds will be called as a coordinate the bond. This is the first coordinate bond, this is the second coordinate bond, this is the third coordinate bond, and this is the fourth coordinate bond. They can suppress a pair of electrons to the central metal ion of the what is called as the magnesium or the iron or the nickel. Okay, so this is all about this one. The other 2 are secondary nitrogen donors. The other 2 are secondary donor. The donor questions, each of which has lose a proton in forming coordinate the bond with a metal ion. There's a porphyrin ring with a tetradentate dinegative ligand. The dipositive cations such as magnesium, iron or the nickel. So 4 pyron rings of porphyrin carrying the substituents other than hydrogen are called as porphyrins. If other than hydrogen atom, they will be called as porphyrins. The complexes in which a metal ion is held in the porphyrin ring system are called as metalloporphyrins. So in the porphyrins, if any one of the replaces by the metals other than the hydrogen atom, so those compounds will be called as metalloporphyrins. Such complexes play a vital role in biological systems. So that is magnesium as well as the iron. If magnesium is there in the metal porphyrins, it will act as a chlorophyll in the plants. If a metal ion is what is called as iron is there, it will act as very very important role, the oxygen carrier through the hemoglobin and the myoglobin, that is the human assistances. Okay. So with the delocalization of electrons in the pyron ring systems, you obtain the stable porphyrin system is the best value of the size of the central hole has been estimated to be 0.2 nm. This is called as 0.2 nm. The size of the center hole, in the center of the porphyrin ring is ideal for accommodating the metals of first transition series or lighter alkaline earth metals. The next you will be come across what is called as another one is very very important, that is the iron porphyrin in heme. So next is iron the heme. So this structure will be like this is the
CH double bond SCH2. This is a double bond CH2, and this is SCS3. This is another nitrogen atom with a double bond CS3. This is SCH2, SCH2, this is SCOH. Fe+2. This is iron, this is nitrogen, this is a bond is there. This is a double bond, this is double bond, this is double bond, and it will be having CH2. This is CH2 and this is SCOH. This is SCOH. CH double bond CH2. CS3. This is CS3 double bond.
So this is called as iron.
Iron proto fire 4 firing in heme. Iron proto 4 firing in the hemes. Okay, so this is all about the structure of this compound. So in this structure, that is this is a 4 pairing in the heme system. That is our body will be contains red blood cells, that is RBCs. These RBC cells will be carries oxygen to different parts of the system by using what is called as hemoglobin and myoglobin. So first of all, the hemoglobin consumes what is called as this one. So this is called as the system of what is called as a pore pairing. So the next is the iron porphyrates. The next is the iron porphyrates, the hemoglobin and myoglobin. All organisms require oxygen in order to survive. So for the human system, or the plants or animals, they need what is called as oxygen is there. So it is formed during the photosynthesis involving biologically important redox reactions. So the different proteins have different tendencies to bind the transfer of oxygen.
These proteins are known as oxygen carriers. These proteins will be called as the oxygen carriers. So the oxygen carriers for the human system, that is called as oxygen carriers. This most important, the two oxygen carriers proteins are the hemoglobin, or called as the hemoglobin, the Hb, and the second one is myoglobin is Mb. So Hb is hemoglobin and myoglobin is Mb. These are the iron core pairing complexes which are oxygen transfer and oxygen storage agents in the blood and muscles and tissues respectively. The myoglobin is a small intracellular protein present in the vertebrate, that is muscles, while hemoglobin is a large intracellular protein responsible for the red color of the red blood cells. The functions of these two proteins are as follows. The first one is a hemoglobin pick up oxygen. The hemoglobin pick up oxygen in the lungs and delivers to the rest of the body. The second one is a myoglobin accepts oxygen from the hemoglobin in the muscles and stores it until needed for the energetic processes. So that is the first one. These two, that is oxygen carriers. The oxygen protein carriers is one is hemoglobin, second one is the myoglobin. So the hemoglobin, it is extracellular fluid, is present in the extracellular fluid system. The myoglobin is present in the intracellular fluid in the small scale, in the small amount. So that is this is the hemoglobin. It consumes oxygen. It consumes the oxygen from the what is called as from the oxygen from the lungs and also different parts of the body. The myoglobin, it stores in the extracellular fluids in the small scale. So that it needs the energy for the body is supplied by the myoglobin. Next question. Okay.